This is the Conservation of Energy Lab, and what you see in front of you is the write-up, so you can come back and pause and write this up if you wish. The purpose is to examine the relationship between the mechanical, potential, and kinetic energy of a marble going down a coaster. And first you're going to have to make a video of the marble coaster, and you're going to save it to your Z drive. Again, it's important to use HD60 to keep the camera still, which means you need to be able to see the whole run in the picture. And we're going to set up a meter stick at the bottom of the video on the table, right below the track. And we'll do that tomorrow in class, and we'll show it to you. After you get your video made, you're going to import the video into Tracker, after you save it to your Z drive, of course. And then you're going to edit the video to the area of the interest, where after you release the marble, and before it stops. Then you're going to track the marble throughout its run, like we've done before. And you know the mass of the marble, which I'm giving to you, is 0.028 kilograms. After you get done tracking it, you're going to go ahead and insert an axis and the correct calibration into Tracker, using that meter stick for the calibration. And then you're going to copy the time, Y position, and velocity into graphical analysis. Remember to label all columns and units. So after you've got the time, the Y position, and velocity into graphical analysis, you're going to make 3 calculated columns. One for kinetic energy, one for potential energy, and one for mechanical energy. We're going to have to be different with the kinetic energy. You're going to want to use 0.7 mv squared instead of 1/2 mv squared. That's because the marble is rolling, and we have to take into account rolling energy. After you get your 3 calculated columns, you're going to go ahead and graph them all against time. And then you're going to answer the following questions. How are kinetic and potential energy related throughout the run? What happens to mechanical energy during the run? And why do you think that occurs? Write-up per group. So one person, whoever wants to, hand in the write-up that you had to do for tonight's homework. The tracks from the Tracker file without the video appearing. The data table from graphical analysis. Please print the table separately, otherwise we do not see all the data. And the graph showing kinetic energy, potential energy, and mechanical energy all on one graph. And again, please print it out separately. And then, if you wish to, you can put on the graph the answers to the 2 questions that you already wrote down. Okay, right here we can see the coaster. This is what you're going to need to do. You're going to need to get the whole thing in the picture. Probably could have been a little bit closer. And down at the bottom on the table, you're going to go ahead and put that meter stick. You're going to calibrate using the whole meter stick. So that'll be 1.0 when you stretch the calibration stick across there. When you put in your axes, it would be good to pull to the lowest point where the ball's at when you're tracking it, and the Y is at the first point when you're tracking it. Your axes will end up looking like this. In the past, we've used specific kinds of velocity, but in this time, you're going to get just plain V. So you're going to put on your table time, Y, and V. And then you're going to copy all of that data into graphical analysis. In graphical analysis, we're going to create 3 columns: time, Y height, and velocity. At first, since you only have 2 columns, the first thing you want to do is make a new manual column. Do not make a new data set, which a lot of people did the past time, because that makes difficulties. So you can see here I now have 3 columns all under the same data set. The first one, which I still have to label, is going to be time. And of course that unit's going to be seconds. The second one is actually going to be the Y position, or the Y height. units will be meters. And then the third one is that velocity, just plain V, not Vx, not Vy, just V. After you get that data in, you're going to have to make these new calculated columns. To do that, go to Data, go to New Calculated Column. The first one we're going to do is potential energy. And the tricky part is down here. You're going to have to create an equation. You don't put any equals, you just put in your first thing. So the first thing will be mass, which is 0.028 kilograms. And then we're going to take it times gravity, which is 9.8 meters per second squared. And then we're going to take it times, and the next thing is going to be the height, the y height. Don't just put in y, you're going to have to pick the variable over here. So I'm going to pick y height, and then I'm done. Now I'm going to make a new calculated column for my kinetic energy. And down here under the equation, because we have the marble rolling, we're going to have to use a 0.7, not a 1/2, but 0.7. And then I'm going to take it times, and then times the mass, and that's 0.028 kilograms, and then times velocity squared. So again, I'm going to pick the variable. I'm going to go over here, variable, pick velocity, and I'm going to make it caret top, that's capital 6, squared. And then I'm done. Now I've got to make a third calculated column. Go under Data again, get a new calculated column. I'm going to make this mechanical energy. And the equation is just going to be the potential energy that the computer's already calculated plus the kinetic energy. So I'm going to go ahead and pick potential energy plus I'm going to pick kinetic energy. And then the computer will do all the calculations for you, which is very, very nice. And that's the end of the video. Thank you very much.